Frame analysis. Video 7. Steel design according to first order theory. Part 1. We have now performed an analysis of the steel frame and want to go on to see if it meets the requirements of the code. We then have the option of designing in accordance with first order theory or second order theory. We begin with first order theory, which means that initial bow imperfection already is included in the design backing formulas and can therefore be disabled. To make a design in accordance with first order theory, we should deactivate second order theory in the analysis. We then move to program part design. Some new data only affecting the design must now be specified. We begin with support conditions. Here input for the active member or all chosen members can be specified. Which members that are chosen is shown in the input window, and they are also identified by blue member numbers. In this case, all members are chosen and member 1 is active. To change which members are chosen, one can double-click anywhere on the screen, which will make all members not chosen, and then activate one member or make a box around several members. In this case, for example, we define column 5 and beams 9 and 10 as chosen, and member 5 will be the active member. We once again activate the option support conditions, and we see that only these 3 members will be affected. Here support conditions with respect to flexural buckling and lateral torsional buckling out of the frame plane can be specified, and by default hinges is applied at both ends. We do not change this, which means that the current buckling length will be the same as the member's actual length. As the design is made according to first order theory, also buckling lengths in the frame plane is required. If no buckling lengths are defined, the buckling length will be the same as the member length also in this direction. Under the option End Supports, 1 or 2 plates at the member ends are defined. Rigid end posts means duplicate plates and non-rigid a single plate. The choice affects the shear capacity. With the option Lateral Support, the frame can be braced with regard to out-of-plane instability by support defined as continuous or as single at certain points. For slender webs, the shear capacity can be increased by applying vertical plates welded to the web. Under the option Buckling Stiffness, such plates can be specified. For standard beams, such plates normally have no impact on the shear capacity. For lateral torsional buckling, the capacity is affected by the level at which the load is situated. This can be specified under the option Load Level. By default, the load is assumed to be situated at the member's top edge. With the option Details, the data that place applies to the active member are presented graphically. The design is performed with respect to the ultimate limit state, but the deflection check for the serviceability limit state can also be performed if desired. It can be done with respect to 2 different criteria, as a proportion of the span's length or as a fixed value. If we, for example, want to control the deflection of the beams, we make all members as not chosen, and then choose members 3 and 6 and 9 and 10, and define a deflection criteria L divided with 300 for all chosen members, meaning the beams 3, 6, 9 and 10.